Gentlemen, I'd like to introduce to you Mr. Nicholas Kalkuta. He's going to take you through introduction to Renewable. You've been introduced to basics of AC and DC, and then you were shown solar cells, and I think you almost dissected a bunch of PV systems. The only thing I want to say is in a few seconds left, not really into his time, about 3 minutes, take a PV system like a rain harvesting and rainwater harvesting system. So in the rainwater harvesting system, you need a roof, okay? Your body. That is your panel. So the larger your roof is, the more water you will rainwater will collect. Then you have to direct it somewhere for keeps. Otherwise, you can go under those droppings and take a shower or gallop some. But once the rain stops, also your water stops. You get the idea? So you must collect this water. So you put gutters. You go where? Then you direct it somewhere. Those are your wires from your panel. And then you need to have a buffer storage somewhere where you can always open the tap and use some. So you need a storage tank. Those are the batteries. So you need solar batteries during the day when it is shining to keep your electricity. Also, similarly as a rainwater harvesting system, when the rain is raining, then you collect your water. When it stops, you should be able to be like a kid and still get your water. So you have a tank. On the tank, you need to know there is overflow. You need to know that there is, when it fills up, you must make sure it overflows, otherwise it will burst. So you learn about something called a charge controller somewhere in the PV system. And then you need something to stop your water from getting out of the tank useless. So you need a switch. You need some switches and circuit breakers in your system. And then you can always collect from your tap by putting a jerry can, a bowl, a cup. Those are your appliances. Whereby you can put a radio, you can put a lighting system, put a TV, whatever you want to use for charging your phone. So I just wanted you now to change your mindset and look at the two comparisons. Just like you looked at a small pipe, the flow of water is constricted compared to a bigger pipe where water runs through comfortably when you are looking at resistance of the wire. The smaller the wire, the more the electrons struggle to go through, and that increases the friction, so you get the small wires heating up. Compared to when you have a big wire where everything is huge and electrons go through comfortably. So I want you to look at these things in that form. With that, when you look at them in that perspective, I think comes easy. All in all, he's going now to take you through the general case of renewable energies. And then he will tell you which one is renewable, which is non-renewable, why is it renewable, and why is it non-renewable. So I hand over now to, I'll be talkative. Whenever I chip in, I'll try to talk a little bit. But the main presenters will always be the ones to give you the credible information. So, Nicholas, you have the floor. I wish you good directions.
Also, good afternoon, gentlemen. I'm Nicholas Kalkuta, as I've already been introduced, from the Department of Physics. So this afternoon, my task is very simple. I just want to introduce you to the different sources of energy, but my emphasis will mainly be on renewable energy sources. As the topic says, it's just an introduction. So we shall just be briefly looking at the different sources of renewable energy. We shall definitely not go into a detailed analysis or how each the renewable sources gives us the different forms of energy, as we shall see. So, I'll briefly introduce the topic and then talk about different energy sources. So, we can basically divide energy sources into renewable forms as well as non-renewable sources. And our emphasis, as I've already mentioned, will mainly be on renewable energy sources. And then finally we shall have a conclusion. So, first of all, of course, I'm sure you all know what energy is, at least we had got that definition even in primary. Can someone remind us of what we mean by energy? Yes. The ability to do work. Of course, you are aware that there are different forms of energy. At least we know potential energy, we know kinetic energy, and other forms of energy. But in this concept, now when we talk about sources of energy, first of all, for example, we know that we need it in order for us to get the what? Energy, isn't it? However, we are looking at a bigger picture. For example, we have electricity here, which was, of course, enabling us to do our work. Otherwise, without electricity, we wouldn't be, for example, able to carry out this talk. So the question is how we get, for example, of course, this is electric energy. So how do we get this form of electricity? First of all, is it renewable or is it non-renewable? So those are the various forms of energies and their sources we shall be looking at. So we are basically saying that energy actually drives life on Earth. And one of the biggest challenges the global world faces today is, of course, the fact that the demand for energy is always increasing. And there are, of course, different reasons or different aspects we can attribute that increase in the demand for energy. One of the issues we can talk about is, of course, the population growth. We realize that the world population now stands at, we're already at 7 billion. And of course, if initially, for example, maybe if you look at an example of a home, initially maybe you were people probably wife and husband. Now, maybe after 1 or 2 years, you've given birth to a child. So you are now 3. So if you were maybe having, let's say, 2 plates, preparing, let's say, 2 plates for food, then because of the third child now, maybe you need to, of course, look at much more than the 2 plates you were used to, and maybe 1 or 2 cups of what? Cups of tea. And of course, that cause, if we are using, let's say, boiling, we used to boil, let's say, 1 liter of water for tea, for example, maybe now you need to boil, for example, 1.5 liters. Okay? Now, if you look at that case, maybe the 1 liter of water you were boiling, you are using maybe, let's say, 200 grams of charcoal. But if you now have 1.5, probably you are going to need maybe 250 grams of what? Grams of charcoal. And so that with increasing population, then the demand for energy also increases. So that means that we need to look at, if we have, let's say, a fixed source, then that means we need probably to look at alternative sources so as to be able to meet this demand in energy as the population Another factor, of course, we can look at is the global economic activity. Of course, with increase in population, different people, for example, can get involved in different economic activities. And those different economic activities, each of them, for example, will in one way or another be requiring a certain amount of energy, depending, of course, on the kind of economic activity you are involved in. The demand for energy will go hand in hand with the different economic activities. Some of them may be quite energy intensive, others may not necessarily be energy intensive. But the fact that as the economic activity increases, then the demand for energy also goes. Of course, there are many other factors we can look at, but these are two of the major factors that result in increase in the demand for energy. If, for example, we look at a case of the total energy consumption. By 2005, the total world energy consumption stood at 13 terawatts per year. That was 2005. And it is estimated that by 2050, the demand will have grown to as much as 30 terawatts. So that means that every year, the total global energy consumption will be at about 30 terawatts per year. Of course, that is an estimation. It could be higher or slightly lower, but it lies within that region. So here, sorry, the figures seem not to be clear. We have a map or a graph showing the total energy consumption. That is in actually the units. We don't have a pointer.
Oh, I can get you one.
The units are in million tons of oil equivalent. So, if we look at that graph, of course, we see that there is the general trend is on the increase, and we have various forms. Of course, you realize that the most dominant one is oil. Now, oil, of course, we know, first of all, the politics that are involved with oil production and generation, as well as marketing. The other biggest energy contributor is coming from coal. You realize, for example, in Uganda, I don't think we have energy production coming from coal. This third biggest energy source is coming from natural gas. Likewise, here in Uganda, we don't. So, this is a contribution from oil, this is coal, this is natural gas, and you realize hydroelectricity, which I think in Uganda, if we are talking about electricity, maybe contributes probably about 60 to maybe 70 to 80%. But if we are talking about energy in general, you may notice that probably biomass, that is energy coming from plants and other residues, in Uganda may be the dominant form of energy. But if you look at that graph again, if you look at this yellow patch here, this is a contribution that is coming from renewable energy. And you can can see that the contribution is not quite substantial, but it's beginning to take root or take shape as time goes by. So, we can now go to the different energy sources, and as I've already mentioned, the different energy sources can basically be grouped into two broad themes: what we call the renewable sources of energy, and then the non-renewable sources of energy. And each of these different sources, of course, they both their advantages as well as disadvantages. So if we talk about renewable sources of energy, which will be our main area of concentration, there are, of course, different sources, including wind, solar, hydro, geothermal, etc., not limited to those only. And the major advantage of these, the renewable sources, is that, as the word says, they are renewable, they are sustainable over a long period of time. In other words, they know if they are used in an appropriate manner, they cannot be depleted with time. In other words, they tend to regenerate themselves over a period of time. We can as well say that they are clean. By clean, it means that we are basically talking about environmental pollution. So we don't have so many, for example, greenhouse gas emissions coming from the major main renewable sources of energy. And by renewable, I mean by greenhouse gas emissions, we are talking about emissions like carbon dioxide, carbon monoxide, methane, for example. All those are greenhouse gases. For example, we also have CFCs, carbon fluorides, which are not environmentally friendly. Of course, talk has been so much, we've talked so much about CO2, that is carbon dioxide emissions, as well as carbon monoxide to the atmosphere, which of course result into global warming. And of course, you are aware that that has been quite a critical issue for quite some time. However, one of the challenges, or what we may refer to as a disadvantage, is that they are not generally easily generated in very large amounts. But of course, some of these issues are debatable. I mean, depending on which angle you look at them, some they will say, if for example, we are talking about hydro, and we are saying not easily generated in large amounts, someone may say, well, that is quite debatable. But as I've mentioned, it depends on the angle you look at each of those advantages as well as disadvantages. Another point is that you really need initial large capital investment. That may be one of the limiting factors. Of course, like I've already mentioned, that one is also debatable, depending at what you are looking at. If you are looking at maybe large-scale production, maybe if there is government involved, then that may not necessarily be a big issue. But if maybe we look at an individual level, then the initial capital investment may be one of the limiting factors or inhibiting factors. On the other hand, we have the non-renewable sources. By non-renewable, here it means that these sources of energy get depleted as time goes by. Examples of such non-renewable sources, we have the nuclear energy sources, fossil fuels, and fossil fuels, that's where we have natural gas as well as oil. That's where all these lie. Of course, oil, we are talking about, again, it can be diesel, it can be paraffin, all those lie under fossil fuels. So the biggest challenge or disadvantage is that they cannot be replaced once they have been depleted. So that means that once the resource has been depleted, then you have to look somewhere else. Secondly, there is high pollution coming, for example, from these fossil fuels. Of course, that's one of the major sources of CO2, as well as carbon monoxide. Other sources like nuclear energy, the pollution may not, in terms of, let's say, greenhouse gas emissions, may not be so much. But there is one of the biggest issues is, for example, in the case of a nuclear accident, what are the effects of such a nuclear accident happening over the rest of the population? For example, we know I think one of the recent nuclear accidents was in Japan, the Fukushima. Hopefully you heard about it. Of course, the accident, where matters was an accident, it was caused by, believed natural disasters, I think an earthquake somewhere, which triggered off some reactions leading to uncontrollable reactions that occurred in a reactor, and the effects, of course, were quite substantial, though not on a very, very large scale like what happened with the Chernobyl nuclear accident in Ukraine, I think, sometime back, was it in 70 something? And up to now, for example, the effects of that accident, which took place more than 40 years ago, are still being felt. So that's why, for example, nuclear energy is not referred to as a clean source of energy. Of course, there are also emissions coming from such kind of sources, but we are saying that compared to fossil fuels, in terms of greenhouse gas emissions, they are on a lower side. And maybe what we may look at as an advantage is that they are widely available as well as affordable. As I've already mentioned, that so-called advantage is also relative or is debatable, depending, also at what angle you look at it. So, as our topic mentioned, or as our topic posed, we shall mainly concentrate on the renewable sources of energy. And as I've already mentioned, these sources come from resources that are naturally replenished. As long as we, of course, know, again, if you don't use it in an appropriate manner, of course, you can end up depleting the resource, and maybe you need time to first leave it to replenish in order for it to, again, for you to be able to use it after some time. So, these forms of renewable energies depend either directly or indirectly on the energy from the sun. So, for example, we have wind, hydro, biomass, and solar, which directly depend on energy heating or the energy that comes from the sun. For example, we know wind, which is moving from one point to another, it occurs as a result of differential heating in different parts of the world, which of course results in changes, for example, in pressure, and therefore you have the air, which is saturation coming, and that gives us the wind, which we can turn, for example, to get wind energy. Hydro, of course, you know the water cycle and how water is generated. Biomass, of course, we are talking about the plants, energy from plants, which we we can either we can tap the energy from plants either by consuming them directly, or maybe harvesting them and to produce fire, or we can get charcoal, or for example we can maybe like sugarcane, we can produce energy, electricity from sugarcane, or we can produce let's say ethanol from sugarcane, like what is happening in Brazil, to drive, for example, to get fuel that is used to run cars. And in Brazil, of course, we really noted that that is now almost becoming a major source of fuel for cars. We also have geothermal, which is mainly from radioactive decay or radioactive elements in the Earth's crust, and the tidal energy, which is basically conversion of gravitational energy. And this mainly occurs, is quite common on large oceans and seas, so we can tap into that form of energy and use it to generate, for example, electricity, which is of course a different form of energy. So this figure here just illustrates the different or the various forms of renewable energy. We have hydropower, solar energy, which is of course the direct conversion of energy from the sun into electricity. I'm aware you've already talked about, or you've already had a lecture on solar cells, so you now probably have an idea how we can generate electricity from the sun using solar cells. From the sun, we may not necessarily get, directly convert the solar energy into electricity. We can, for example, first convert it into heat, and then trap that heat into another form of energy. For example, we normally use, for example, this heat from the sun to dry different crops. For example, it can be maybe coffee, or just harvest your coffee and just put it out in the sun. So in that case, you are harvesting the energy from the sun directly in form of heat. You can convert it into electricity, or you can again use it to, let's say, heat water for bathing, or on a larger scale, they can heat water to produce steam, which steam can be used again to generate electricity. So, one of the renewable forms of energy we want to look at is the wind energy. And it is taken as a global clean energy source of energy, and of course it is also widely available. So what you just need to do is to identify a good location where there is, for example, high speeds of wind, and then that should be an ideal place, for example, to position your wind turbine. So how do we trap energy from the wind? Basically what happens, we have blades which are attached to a turbine. So these are the blades that are used to trap the energy. Basically what we do is to trap the kinetic energy of the wind. Now, the kinetic energy of the wind is turned into mechanical energy by the turbine. And then we can convert the mechanical energy into electrical energy. So the best position, of course, to locate your wind turbines should be at areas that are situated at very high altitudes, where, of course, such an area should be free from wind breaks or wind breakers, because you need high speeds of wind to be able to drive your wind turbines. However, one of the disadvantages of this form of energy is that as these blades are rotating, they then produce a lot of noise. And therefore, you find that it is not an idea to locate, for example, such kind of, if for example it is on a large scale, you have, for example, a wind farm, you have thousands of these turbines rotating. The amount of noise that is generated is quite high, and it may not be friendly, especially if it is located in, for example, a residential area. Another effect is the visual impact on a landscape. I mean, people have debated this for quite some time. Some people will say these things look ugly and they wouldn't want to look at them. For example, they say you can't rotate maybe such kind of things in my farm because they don't look nice. That's the reason. And someone is saying that is the very reason for you not to locate, for example, a particular kind of wind farm in a given location because he or she doesn't enjoy looking at them. And also another factor is the impact on birds' life. As these blades are rotating, if there is a bird that is flying by, it can be easily killed by these blades. So environmentalists, of course, and animal bird conservation have had also big issues with wind turbines because of their effect on birds. They tend to be killed so much by these turbines. So those three, maybe, of course, now looking at the advantages probably as well as disadvantages, we tend to weigh the two. And of course, depending on how you look at it, you may choose which form of energy to use or whether it is worthwhile investing in or not. The next form of energy, renewable energy, we want to look at is the hydro form of energy. If you look at, for example, our case here in Uganda, you realize that we rely heavily, if we are looking at energy in the form of electric energy, I think close to 80 or maybe 90% of our electricity is generated from hydro, from water or hydroelectric energy. So it is a major source of electrical energy, most especially in developing countries. This energy also, the hydro energy, is actually also harvested from kinetic energy of moving water. So that kinetic energy is again converted into mechanical energy using turbines. And then from the mechanical energy, we have to convert it again into electric energy using generators. So on the right here is just a simple diagram, illustration showing hydroelectric power generation. This, of course, here is the power station. So we basically we need a high altitude reservoir, which is basically a dam, and then we have what we call a penstock, which is just a tunnel through which water will be running at very high speeds. So this water here with a lot of kinetic energy is now it's this turbine here, so that the kinetic energy of this running water is now used to run this turbine, which converts now the kinetic energy of the running water into mechanical energy, and then the mechanical energy is converted into electric energy using the generator. So from there then you have the transmission lines. So the rest of the water now flows into a long water reservoir, which sometimes can be a river. So you now, the water has of course to continue running. So sometimes it can be On a higher altitude, because sometimes you have to channel it into a dam, of course, which definitely has to be located on a higher altitude, and then allow it to flow through the turbine so as to harvest the kinetic energy of the running water, which again converted into mechanical energy, and then later into electric energy. Of course, there are also advantages and disadvantages of this form of energy. One of the disadvantages, of course, is that such kind of system requires large chunks of land, which in some cases may necessitate displacing people from their locations. They have to be resettled somewhere else. And another effect is, for example, on aquatic life. If maybe you have to channel or maybe locate your hydropower plant on, let's say, a river or a dam, then you will have to, of course, with the kind of setup that is involved in such kind of construction, you will somehow affect the aquatic life, and which will definitely, I mean, if some people, they have been dependent on such kind of, like, for example, fishing. So once you construct such kind of system, then maybe fishing in this region is likely to be prohibited. So that means that first you are affecting maybe aquatic life of, let's say, the fish, as well as affecting their sources of income for some people who may be living around such kind of setup. Please, in case there is a question as I go along, you are free to ask if, in case you need clarification on one or two issues. Another source of energy is the geothermal energy, and we are saying that this is basically natural heat that is generated within the Earth's crust and can be trapped inside the Earth in form of, for example, molten magma, which can be released if, for example, maybe there is a volcanic eruption on, let's say, on a mountain, as long as that mountain is still active, or it can be stored deep in the Earth's crust in the form of water or air that is flowing within the Earth. So this water, which is of course heated, water or air that is heated, can be released into the surface of the Earth through vents, and it is mainly common, this form of energy resource is common in areas that are prone to earthquakes. And of course, if we look at, for example, volcanic eruption where magma is released, there are some harmful gases that may come with the release of this molten magma, and of course, these gases, their effect on the environment may be quite substantial. Of course, in Uganda, there are locations where we have this form of resource available, but it is not yet harvested, or it's not harvested optimally to, for example, generate electricity. But if we look at our neighbors, for example, Kenya, I think they've gone so much into geothermal as a source of energy. We have, of course, you've heard of hot springs, for example. If we have hot springs located in different areas across the country, I know some, I think, in Western Uganda, we talk of Tidal. And I'm told it's just water that is gushing out of the earth, as for example, we see in this picture here, this is hot water being released from the Earth's surface. And if, for example, I've not been to, for example, some of these hot springs, for example, in Western Uganda, but I'm told that you can just boil an egg. You can just boil eggs using that water that is coming directly from the Earth's surface. So what happens, you can harvest that energy, that heat energy, and use it to generate electric energy, for example. Or you can just get that water, and maybe if you are used to bathe in hot water, like myself, then you don't need again to buy charcoal to boil what? To boil water for bathing. You can just use that. So that is a form of energy. However, on a large scale, on an industrial level, once you identify that resource, you can now drill deep into that resource so as to trap that hot water, or which may either be hot water or vapor in form of air. You trap it and generate steam. If it is not very hot enough, then you can again heat it further to generate steam, and that steam you use it to run a turbine. So you have steam turbines here, which again are from you use again generators. Of course, this steam here you run the turbine to generate mechanical energy, and then that mechanical energy is converted into electric energy using the generator. Of course, once you extract that energy from the steam, then the temperature of the incoming water or steam will now drop down. So what happens now, you can again drive this water that after generating, trapping the energy from the steam, you can now again recycle it into by drilling an injection well, so that again this cold water now which is being injected is again heated by this resource and then extracted, so that you have this continuous cycle taking place, in which case you will be able to generate electricity from this kind of resource. Of course, one of the challenges is that, for example, the location of these resources, and as I've already mentioned, that they are mainly common in regions that are prone to earthquakes as well as volcanic activity. Of course, that then becomes a disadvantage for such kind of sector or industries that are located in that regions. Of course, if it is a very large earthquake, then it is likely to affect your construction or your structures in here, unless, of course, they are built with that effect that you have you are building in an earthquake-prone region. So in which case your structure must be designed in such a way as to be able to withstand the strong earthquakes that may be occurring in such regions or such areas. So the next form of energy that is renewable energy is biomass energy, and this is mainly obtained from plants. We have plant wastes, crops, landfills, municipal and industrial wastes, as well as, of course, animal residues. And this can come in very many or various forms. It can be solid form, liquid, or gas. In solid form, of course, we can either talk of firewood harvested directly from plants that have been dried, or the firewood or the logs maybe can be cut and converted into charcoal to get that form of energy. Or if we look at maybe animal wastes, we can produce, for example, biogas You can have a biogas plant, for example, in which case now the energy we shall have will be in form of gas. Or you can harvest, for example, maybe from sugarcane production. You can generate fuel for example, to drive your cars. So here there are different forms, very many forms, and it's quite wide and diverse. Now, the percentage contribution or the precise contribution to the total energy consumption is quite uncertain. Most especially, we know that this is the major form of energy. For example, in the form of, if you look at the case of Uganda, we largely depend on charcoal as well as firewood collected directly from the bush. So in such a particular case, it becomes quite challenging to quantify the amount of energy, amount of contribution to the total energy demand. But it can be done it can also be done on a commercial scale. So in this picture, for example, we have now what is of course common to most of us, how we harvest energy from, for example, plants in form of firewood. What is quite surprising and interesting, I'm used to using charcoal in a city, but you realize that for her, she said, no, I can get my city and then use the firewood directly to produce the amount of energy she may want, for example, to prepare a meal for herself and the rest of the family. So, as I've already mentioned, this form of energy use or energy generation is quite difficult to quantify in terms of its contribution to the total energy demand, because someone just goes to the bush, collects one or two pieces of wood and goes home and immediately starts using it. However, it can also be done on a commercial scale, as we see in this case, for example. Here, this is now where you have firewood being generated on a commercial scale. Of course, you see these forests that have been grown. So this is on a commercial scale. From this, of course, you can either use dead firewood directly, or you can, from this, generate charcoal. And by the way, charcoal can also be generated from other sources, for example, residues from sugarcane, from, is it called bagasse? Waste from that, you can also generate charcoal, which in this case is not the real charcoal we are using to, but sometimes I think it's referred to as briquettes. So you can generate that different forms from here. If it is sugarcane, as I've already mentioned, like for the case of Brazil, which is doing it on a large scale, you can generate fuel to run or to use in cars. So, another form of renewable energy is tidal energy, and this is, as said, kinetic energy of incoming and outgoing tides. Tides, these are strong waves, mostly common on oceans and large water bodies. And those strong waves come as a result of the differences in the gravitational force. As a result of the Earth's attraction on the water bodies, it may result in these large water waves, especially if it is on a large water body. So this kinetic energy of these strong waves can also be harvested and converted into electrical energy using what we refer to as tidal energy generation. generators. So what, of course, is shown here, these are the strong waves, the strong tides, which mainly occur on very large water bodies. So such kind of energy can also be harvested and converted into electricity, as illustrated in this picture here. So this is our sea or ocean with very, very strong tides. So what happens, you have to make sure you build a sanctuary estuary where you, for example, you will have our turbine here. So as these strong waves come in here, then we will drive this turbine. Of course, the turbine is all, the generator is also located here. So the kinetic energy from these strong waves is converted into mechanical energy by the turbine, and then the generator now converts the mechanical energy into electrical energy. So as this water, of course, as it loses its energy, it flows into this other reservoir, what we refer to as an estuary, and now you realize that its level has now gone up compared to now the level of the sea, which is now experiencing what we may refer to as a low tide. Now, because now the water level now here is higher, if we have a low tide here, now the water will have to flow back into the sea. So that means that your turbine and generator here must be a special one, which should be able to run in either way. It shouldn't be a one-way, it should be a two-way turbine. Otherwise, if it is one way, then you will not be able to again harvest energy as the water is again flowing from this estuary back into the sea. So this has to be a special kind of turbine that should be able to run in two directions. In other words, shouldn't be uni. Yeah, that is one direction. So the other form of energy, renewable energy, is the solar energy. And as I've already mentioned, we can harvest this in different ways. First of all, we can harvest heat directly. As a simple example is, for example, if you put maybe your clothes after washing, you just put them outside on a wire or even on grass and leave them to dry. But in other countries that are not so lucky enough to experience this natural form of energy, they will have maybe dryers which are running on electricity to dry their clothes. Crops, we also, it's also common, those who are normally grow coffee, maybe beans or what, you always just leave them outside in the sun to dry. But some of these things here, we take them to be obvious, but there are some countries that are not so lucky enough to experience this natural form of what? Of energy. So that is one way we can use it. Of course, we can also use it to heat water, maybe for boiling, just get your water, put it on a basin, and leave it outside for some time. You realize, of course, that is not an efficient way of harvesting this form of what? Energy, because there are so many losses that are involved. So, energy, that's why I'm saying two categories. It can be solar photovoltaic systems or solar thermal systems. Now, of course, these solar thermal systems, this is quite different from, for example, harvesting heat directly from the sun. Now, the photovoltaic systems, those ones now harvest the energy from the sun and then convert it into electricity directly. But solar thermal systems, you harvest energy from the sun and then convert it into heat. Now that heat can either be used for, let's say, heating water, or can be consumed directly, or you can again use it, for example, to heat water, superheat water to produce steam, and then you use steam to generate what? Electricity, if you have a steam turbine. So, in this diagram here, of course, these are photovoltaic systems, whereas these are panels installed on a rooftop. So these can be used to generate electricity directly, which can be consumed directly. Of course, if it is a big system like this, then of course there are other systems that are involved, which we refer to as balance of system components. Either you've looked at them, or we shall discuss them during the course of the week. Of course, there are challenges or disadvantages as well as advantages of such kind of systems. Of course, one of the limiting factors is that, of course, we all know that at the moment panels are quite expensive. There are one or two reasons, of course, for that, as we shall see later as we go on with the course, and we should be able to explore more of these systems. So apart from solar photovoltaic systems, we also have solar thermal systems. This is a solar water heater, which can be either installed on a rooftop, or you can install it, let's say, on a ground level. But of course, these tubes here are made of glass, through which water is running. So if it is, let's say, on a ground level, then that means that they should be located in areas where children will not be playing otherwise. And if maybe a stone hits any of this, then your system will go down. So these are solar water heaters, which of course can be used either on a small scale or on a larger scale. But if we go, maybe we can also look at the advanced systems which use what we may refer to as heliostats. What happens, you have energy coming from the sun, it is falling, let's say, on a dish. So the energy in the form of heat falling on a dish is reflected onto what we call a receiver somewhere. Now that receiver contains what we call a working fluid. So the energy coming from the sun falls on, let's say, on a dish, which is in the form of a mirror, reflects it onto a receiver. So the receiver must be something that is able to withstand high temperatures. So through that receiver, water is running, and that is normally used to produce heat water and produce steam, which steam can be converted to generate electricity. That is mainly on a very, very large scale at industrial level, meaning to produce energy that can be fed into the main grid, but may not necessarily be consumed locally. So basically those are the various forms of renewable energy. So in conclusion, therefore, we've talked about the energy resources, and we classified them under two categories, that is renewable as well as the non-renewable energy sources. And we also briefly looked at advantages of some of the energy sources as well as the disadvantages. And we went ahead to look at the various forms of renewable energy sources in detail. Well, not so much detailed, but at least we gave a brief overview of each of the various forms of renewable energy. We may not have exhausted all the forms. For example, maybe we can also talk about hydrogen as another form of renewable energy. And as I've mentioned, advantages and disadvantages of some of these forms of energy sometimes may depend on from which perspective you look at them. So, one may ask that maybe given the advantages and disadvantages of renewable versus non-renewable energy, for example, if we look at maybe the effect on the environment in terms of global warming, for example, we look at maybe if we just pick one case of, let's say, fossil fuels against, let's say, solar energy. Why can't we, maybe why can't governments pass either law, resolution, or one that maybe if we go into one form of energy? Challenges are that some of these forms of energy are not fully developed, either not well commercialized to be able to be used on such large scale. But of course, there are countries, of course, that are moving into that direction. But at the moment, we are not yet there. But it is hoped that with time, maybe we may reach a case or a level where maybe we are relying, let's say, on renewable energy, maybe at a percentage, probably 50-50 or 40 to 60%. Of course, if we look at maybe the developed countries, for example, of course, some of these are large consumers of energy, you realize that there is a policy of moving towards maybe renewable energy, renewable sources of energy. If you look at maybe Germany, for example, where they promoted solar energy to a very, very large extent, whereby government gives subsidies. If, for example, you install a solar system onto your rooftop, you may produce energy which you can consume locally, but if you cannot consume what you are producing, then you can always feed to the grid at a rate which may be beneficial compared to, or may be higher compared to the rate you are buying from the grid. Other countries like Denmark and Sweden, for example, have highly developed systems of wind energy. Of course, as I've mentioned, energy farms must be located in areas, especially high altitudes, where there are large wind speeds. So there is hope, renewed hope that maybe we are moving more towards renewable sources of energy, which are actually referred to as clean sources of energy. And by clean, in most cases, when someone says it's a clean form of energy, we are mainly talking in terms of the greenhouse gas emissions, CO2. As you know, the impact of these greenhouse gases on ozone, which is, of course, protecting us from the negative effects of energy that is coming from the sun, of course, with the global topic of global warming, which results in climate change. So we can, of course, this discussion can go on and on with different divergent views, by the way. But basically, this is what I can say about renewable sources of energy. So I thank you for listening. I think now the floor is open for discussions. There could be questions, could be contributions, additions, or any other views that is related to different forms of energy we have looked at or discussed. Thank you. Yes.
We consider what we consider as renewable energy sources. We only look at the resource the system is getting the energy from, but we also look back at the production cycles, say if they are making solar. It's very high energy intensive, and I'm sure part of the energy that makes the solar come from all power. So essentially, the whole solar thing is not clean energy because you make silicon wafers and then go and everything. It's all powered by diesel generator somewhere now. So it's entirely not clear. And even melting the engines, making them get from, say, huge, whatever they are called, where they're melting, mixing iron and carbon, so they're emitting the CO2 or food, any other gas. So we only look at the energy resource that is driving the system, or we also look at the cycles, production cycles behind the system that are created the system.
Yes, of course, as I mentioned, that some of these advantages or disadvantages, some of them are debated. But when we talk about, one of the advantages of, let's say, solar PV, we always mention that does not produce any gases, that there are no moving parts, that it is actually a clean form of energy, isn't it? But if you look at it that way, then it's like if you just look at the final product, the panel is there, you've installed it, and that's all. But of course, to get to that level of a panel, it goes through various processes. And those various processes may not necessarily be clean. Those industries may be, of course, there are definitely wastes that are being generated, and of course, maybe gases and so on being emitted. Even then, after maybe your panel, because most of these have a lifespan of between 20 to 30 years. After 30 years, maybe it is no longer effective in terms of energy generation. The question is, where do you put it now? Do you recycle it? Can you recycle it? Or do you just throw it away? And if you just throw it away, isn't it then a waste to the environment? Isn't it going to pollute the environment? So if you look at the whole process, if you put it into the picture, then of course it may not necessarily be a clean source as we tend to understand the clean form of energy. But if you look at the whole picture, you compare it to other sources, then you realize that maybe the amount of emissions, the amount of waste being generated using this form is comparatively lower compared to other forms of energy. So it's not like an ideal case that completely 100% there is any emissions or any waste or anything. There is definitely this as you go through that process, but you look at the pros and cons, advantages and disadvantages. How much are you generating, are you releasing into the environment against how much you are gaining or are generating? So it is not a purely clean as in the cleanest, if you look at the concept of cleanliness, it may not purely be a clean source, but compared to other forms of energy, then we can generally say it is a clean form of energy.
I think looks like renewable energy resource.
Well, hydro is a renewable energy resource, but in this particular graph, I think the emphasis was mainly on the different forms of energy, on how each of the different forms is contributing to the total energy demand. The emphasis was not necessarily on renewable versus non-renewable. While this was brought into perspective, the emphasis mainly on this was on wind and solar, because those are the emerging technologies or emerging forms of renewable energy that are yet to, well, they've already penetrated, but they are not at the level they are expected to be at. But otherwise, hydro is a developed technology which has been used for quite some time, and as you can see, its contribution has been quite substantial. But if you look at these other renewables, mainly here, the contribution is actually wind and solar on this. You realize these emerging, we can call them emerging technologies, matters they've been there for quite some time, but they've not been able to penetrate the market. Of course, solar energy, the research intensified, I think, was it in the 77 when there was an oil embargo and the Arab countries, when the world was almost not getting the energy expected from oil. That's when the research in solar energy intensified, because they had to look for alternative sources of energy. But after that oil embargo, when now oil again became available, then the research almost went down until again in the 90s, when again peaked up. Wind energy has been around, most especially in Europe, Denmark, Sweden, Germany. Those have quite a number of energy, quite a number of their energy coming from wind. But if you look at the rest of Africa, for example, maybe we can talk of South Africa. They have quite a number of solar farms as well. Of course, there are strong winds along the ocean or along the coast. So in that case, you find that they are developed, their energy, energy coming from the wind is quite developed. So this graph, the emphasis was not mainly on renewable versus non-renewable, but they were trying to look at the contribution from the common sources of energy. But otherwise, hydro is a form of renewable energy.
Okay, it looks like we need to thank Mr. Florida. If you don't mind, we can so again, you will be meeting him tomorrow